The big thing in this section is this fact. You will always know this. In a triangle, what am I talking about? What if you were reading that to yourself, how would you read that? Measure of angle B plus measure of angle C. Correct. So what am I saying? I'm saying the measure of these angles, all added together, must equal something. What number do we seem to always be using? Guess what? They always, in a triangle, for it to be a triangle, the angles have to add to 180 degrees. So in any triangle, if you have the measure of two of the angles, can you find the third? If you know two of them are equal, and they just give you one of them, you got to be able to find a third. Okay? Like I was talking about having a straight line. You know, remember how we had, if you have two angles that create a straight line, what do we know those two angles add to? Anytime we have two lines that intersect, what do we know about the opposite angles? They're what? They're congruent. They're vertical angles. This is another one of those facts that you'll always know. If any triangle, the interior angles will always add to 180 degrees. Yes?
If you look at how, like, when you mark the two for the angles and stuff, they look like triangles.
Yeah, they do. Okay? It's just that simple. So as you would imagine, there's going to be a lot of different problems that we will create from this. One other thing that we need to talk about is what is called an exterior angle. Let's draw this, for the most part, the same triangle. Now I'll label it A, B, C. Okay, we know that this plus this plus this equals what? 180. Now, what an exterior angle is if I was to put my ruler on one of the sides and I was to just keep it going and extend it on like this right here, if we call this angle 1, this angle 2, this angle 3, this is angle 4. This is angle 4 is called an exterior angle. What do you think angle 1, angle 2, and angle 3 are what? Interior angles. That's easy enough, isn't it? Now, just because it's on the outside does not mean it's an exterior angle. It has to be extension of one of the sides. And the angle created by that extension, see how I extended AC and just kept going? It created angle 4, and angle 4 is an exterior angle. You could draw some weird line right here. Call this angle 5. Why would angle 5 not be an exterior angle? It's not the extension of one of the sides, is it? So you can draw more than one exterior angle, of course. Now, here's the deal. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180, right? We just learned that. Everybody look at this. Measure of angle 1 plus, stop, put your pencils down. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. Correct? The three angles inside a triangle will always add to what? Well, what do we know 3 and 4 make together? Don't they make 180? So angle 4 plus the measure of angle 4 plus the measure of angle what? 3 equals what? Looking at these two on top of each other, what has to be equal? Isn't all of this the exact same thing? So wouldn't this have to be the exact same thing as that? Wouldn't it? It's the same amount left out of 180, isn't it? So the measure of angle 4 has to equal what? The measure of angle 1 plus the measure of angle 2. What this is called is the exterior angle theorem. An exterior angle will always equal the sum of its remote interior angles. And as corny as that is, what you guys probably weren't around the days where you didn't have a remote control for your TV, right? Everyone agree? I hardly was. I wasn't hardly around then. Okay? The remote interior angles are the ones that needs a remote to deal with because they're not right beside it. See what I'm saying? 4 is right beside 3, so its remote interior angles are what? 1 and 2. If I was to draw this one, call it angle 5, what would angle 5's remote interior angles be? 1 and 3. If I was to extend this one out right here and I was to call this 6, what would 6's remote interior angles be? The ones what? Not beside it, right? Okay? And if you had 2 and 3, they'll always equal 6, won't they? Okay. All right, let's get our workbooks out. Everybody write that down. If you need to finish up writing this part right here down. Okay. Find each measure. Let's look at these right here. Okay, what do we know all of these are we're looking at? What are they called? What do we have a bunch of? Triangles. We got one rectangle. Of that, we got a bunch of triangles. What do we know about a triangle? What is this section about? What is this section about? The angles will add to 180, and then we find a little thing to add to that, right, Mr. Clutter? That about the exterior angles. So if this one's 80, this was 73, what's left for angle 1 to be? Well, you simply take 80 plus what? 73, and you take 180 and you subtract that from it, right? So 80 and 73 is 153, which leaves me what? 27 degrees for angle 1. You guys think you can handle that? Right here. This is the one people have problems with. Let me zoom in a little bit tighter here. It's easy when they give you 2 of the 3, isn't it? What do they give you here? Only 1. Okay. So, what are they saying with this and this? They're congruent. So, how much is left for both of them to be combined? 34 degrees for both of them. What's the only way to split 34 up to where it comes out even? So you get what? Right? Come up here, Saber. Get one of these. Okay, they want us to first find angle 1 on number 3, correct? So angle 1 for this one right here. Can I do that easily? Do I even need to worry about this side? 85 and 40 is what? 125. So how much is left? We have to go 180 minus 125, right? So what's left for angle 1 to be? Huh? Okay, so that's the answer to number 3. If this is 55, what's 2? Can you tell me why?
Vertical angles.
Vertical angles, very good. This is 55 and this is 55. What's this one got to be?
70.
Why?
The equals 110.
I'm not saying you're wrong. Just why?
Because the other one's
These add to 110, and when he subtracted 180 minus 110, what did he get?
They're consecutive interior angles.
No, nothing's parallel necessarily. Please don't holler out stuff. Your heart's in the right place. Just might confuse some people. Okay? I mean, that's pretty easy, isn't it? Now, let's look at this one. This is number 6 through, what? 8. First, they want us to find angle 1. Well, there's a couple of ways. Here's the deal. If you don't ever remember the exterior angle theorem, you still, if you have these two, you can still find this, can't you? 70 and 55 is what? 125? So this has to be what? So what does this have to be? 180 minus 55, which is what? Now, it's easier if you remember the exterior angle theorem that you realize, excuse me, that these two added together equal that, correct? But, you know, you do know that this and this have to add to 180, correct? So, I mean, it really is something that you should be able to find yourself. What about angle 2? If this is 55, what's this? They like that number 55, don't they? Okay, if this is 150, what's this? Very good. How do I find angle 3 now? 30, add 30 to what? Now I get 85, which makes this what? 95? Not too terrible, is it? Can we do this? All right, let's go on to one that has some the things you guys love on them. You will have some problems. We will do number 21's in the back of the book, so I'll do it. Let's look at number 21 here. They ask us to find what? Measure of angle what? ABC? So this is what they want us to find. You can do however you want. Okay? You got to realize this is an exterior angle and these are its two remote interior angles. This angle will always equal the sum of these two. However, if you want to stay with these three add to 180 and 48, what's this angle? Can no one tell me what this angle is? Huh? What equation could I write here? What do I know about the angles inside a triangle?
2x minus 15 plus 6.
So 2x minus 15. But what do I know about the three angles of a triangle?
Equal 180.
They add to 180 degrees. So this plus this plus this has to equal what? So 2x plus or minus 15 plus what? X minus 5 plus what? 32 is equal to 180 degrees. Well, if it looks weird, what do I probably need to do? Combine some like terms. 2x and x is what? Negative 15 and negative 5 is a what?
Negative 20.
Plus 32.
Oh, 180.
What am I going to do now? 3x is equal to what? What am I going to do now? What is x equal to?
Whatever that
3 we're going to 16 5 times with 1 left over, 56. Now, is this the answer to the problem? Quiet, please. No, it's not. What did they ask for? That angle right there. And it's x minus, whatever x is, minus 5. What is x? What is x, I said? So it's 56 minus what? So your answer now, what's the other way you could have done that in the way? The reason I did it this way is because I'm betting the back of the book did what? Because you know those ones I told you that are highlighted in green? They do those step for step in the back of the book. They're trying to help you there. Anytime it's got a green circle. How'd they probably do this one in the book? What theorem did they probably use? The exterior angle theorem. Their equation is probably this. 148 is equal to 2x minus 15 plus x minus 5. So someone look in the back of the book and see if that's the equation they started with.
Yes.
But do they end up getting the same answer we do? Do they? Okay. So there's more than one way to skin a cat, huh? It doesn't matter. Either way is just as right as the others. That's why I wanted to do it this way, because you have this shown this way. But the thing that you guys have got to get, because you could figure out the exterior angle just by knowing that all of them add to what? 180. It's kind of an extension of that. The main thing from this section is to realize that what do we know about all the angles inside a triangle? They add to 180. Okay, your assignment. It has changed since we put it on, I couldn't Canvas last. I kind of changed it a little bit. 4-1. Numbers 4 through 13 and 15 through 26. If I'm going to cut down the problems, you better follow directions. Originally this was 1 through 26, so I took away 4 problems. I better see labeled figures, large, well, not super large, but not inside one line, please, about 4 or 5 lines tall. I want the angles in them. I want them labeled with the, they don't have to be works of art, but I want to be able to see if you have any idea. And then, guys, when I say write the problem, and the problem is, the directions are, you don't have to write those in the bold, and it says what, find the measure of angle ABC. On number 1, you would need to write angle ABC, and then beside it, you ought to have, let's say it was 50 degrees, you ought to have 50 degrees with a box around it. That way I know to look over here at your picture, okay, they do know what they're doing. Angle ABC is 50 degrees. You understand? Has everybody got that down? Let's go to, it's on to, well, and I changed this too. There's 4-2. Tried to make it a little easier as well. It's numbers 9 through 15, 17 through 22, and 24 through 32. Not nearly as many problems. However, like I said, if I'm going to do that, they had better be done right. You don't show your work, you don't take the time to prove to me you know what you're doing, you don't grade and correct, it's kind of a double-edged sword. You're going to get less and less credit. Some of you may have figured out